how we can address it. So then we need to focus on certain parameters and how we can detect those parameters to address these issues. So we'll talk about those. And so, as I said, we'll come up with a technique here. The tool is called the gene scan, and that we can use it to sense some of the heme proteins. Heme proteins is something we have hemoglobin and myoglobin we'll talk about here, and that we can do it in real time. So in the outline, first I will introduce you what protein means, because we all are physics students. So yesterday you must have heard about Professor Biswajit's talk. He just gave you a little introduction how we can use the quantum computation in understanding the biology. So we'll talk about the proteins, and then basically the two of the heme proteins, and then we'll come up with that tool which is completely from physics. We'll understand physics, how we can use it to sense these biomolecules, and we'll do it exactly in biological freedom. Like we all know that everything, suppose anything happens to us, normally doctor prescribes the 3 tests. One is blood test, urine test and stool test. These 3 is very, very important to identify many issues in our body. Those are the prime ones. So we'll see how we can sense hemoglobin in our blood. Okay, we have done experiment in human blood. And the next one, to sense myoglobin, we have used artificial urine, because these are related with respect to some of the diseases. Okay, so we'll summarize, and finally we will acknowledge people who are actually contributing. We are sitting in the office, but actually the hard work is done by students. Okay, so we need to give them credits. Next. So this is how the proteins are made from the DNA and RNA, and then the protein is a process of transcription and translation. And basically protein is a chain of 2 amino acids with a basic building block is a single amino acid. By using this chemical reaction process forming a peptide bond between one amino acid to other, we do it. And where it is done basically inside a single cell of our body. And inside the single cell we have a small organelle called ribosome. So this ribosome is the factory. Like we make different toys in a different factory. So similarly our proteins are made in that factory named called ribosome. Those are like very tiny ones, less than around 10 nanometer size this machine is. Okay? So once the protein is synthesized, it can attain certain structure. For example, our hands are made to do certain work. Similarly, protein structure is also related to a specific work. So this protein can have a primary structure or a secondary structure or tertiary, or a flower like is called the quaternary structure. Any state it can attain. And please remember, with respect to our human body, the structure function relations are 1-to-1. Sometimes it is also 1-to-many, but mostly it is 1-to-1. Therefore, a particular structure can do a particular work. Okay? So let's first talk about this hemoglobin. We can just see the hemoglobin attains the quaternary structure, and in each, so it has 4 groups, and each one will have a chemical compound called this metal porphyrin. It has a iron at the center of it. That's why we say that this is the heme group. The iron name comes the heme group. And the main function is what it does. It collects oxygen during our respiration process, and then it binds with hemoglobin, this protein, and then finally release it to the tissue, because we need oxygen throughout the body, and especially the brain cell. So the clinical significance is, if this hemoglobin is less, then we come up with a disease called, that is anemia, anemic condition. Or even if it is high, we have disease called heart disease, some pulmonary diseases, and it can have the smoking and hypoxia that can cause this condition called high hemoglobin level, or medically it is called polycythemia. Okay, so that's why it is very important to measure the concentration of hemoglobin present in our body. Okay, similarly, like this is the structure of myoglobin. It has a only tertiary structure, not the quaternary structure. skeletal and heart muscle. In our muscle cells, the oxygen is supplied by this myoglobin, and it is found in the cytosol in the single cell. What are the clinical significances? It is also a key biomarker, and that can be helpful for diagnosing disease like rhabdomyolysis, acute myocardial infarction, ischemia, or trauma in our urine or in blood plasma. Okay, sometimes we get concentration like even 60 micromolar in our urine. So the basic idea here is like how we can sense these molecules by using the clean technology for optical technology, because nowadays the current practices completely rely on chemical using. Like you need to bind with a certain chemical to catch another chemical. But without using chemical, how we can use physics, a clean technology for optical tools to sense these biomarkers. So therefore we propose here a G-scan tool, and it is basically classified into called closed aperture and open aperture because it has specific sensitivity with respect to the nonlinear refractive and absorptive properties. So this is the setup what we have developed in the lab. So we don't buy any commercial instrument, we develop our own instrument to do it. So that's why I encourage students to, you can keep interest on this because for instrument development, okay? Because you can make, because in research you need flexibility. So as you can see, we just developed this instrument in the lab where a laser light is guided, and finally we are focusing the light with this lens. You create a, when you focus, there is a distribution of intensity. Intensity will vary in the focal plane. Now, when you scan the sample on the focal region and you measure transmission as a function of the scanning distance, this geometry, and finally you measure the transmittance as a function of detector, you just hold. Look at me when I say, then only you click, otherwise don't click. Okay. So this geometry is called open aperture because we are not the whole transmittance of the light, because some light is only blocked and only a center part is collected, then because it is only sensitive to refraction. Okay. Now we can go with the open aperture where what we do is we don't block anything, we collect all the light and measure the transmission as a function of scanning distance. So this geometry will be sensitive to absorption properties, not the refraction, because we don't block anything. So these are the two parameters what we can look for to sense these biomolecules that I can use. So as I said that how based on what concept this whole experiment is designed, it is coming from one of the most beautiful and magical branch of physics is called nonlinear optics. Mostly students, because you are graduate BSc level students here, but when you go to MSc level, master level, you have the opportunity to learn this subject, because in higher level you need to learn how light can propagate in a nonlinear medium, because we all know that in any light matter interaction, when light interacts with the material, the dipole oscillation takes place, because that is the disturbance. And if the intensity of light is very low, that means lower than the interatomic field strength, then the oscillation is harmonic. So then we can write the dipole moment can be directly proportional to the electric field. But the moment you see higher intensity light, that means that can cross the barrier of interatomic field strength, then the path of nonlinearity takes place, because the dipole oscillations are no more harmonic, it becomes enharmonic, and the displacement can never be directly proportional to the disturbance what is applied. So here, therefore this equation dipole you can change it and will get higher order terms, and this is the infinity series, and you get second order, third order, fourth order like infinity series. And here the second order is for the second order nonlinearity, and third order the chi2, chi3 are the nonlinear susceptibility, just like this is the linear susceptibility. Okay. the refraction part as well as absorption part. And mostly this nonlinear susceptibility, when you talk about this chi2 and chi3, they are very specific to some of the structure depending upon the which order it is. Suppose let's say chi2 is very specific to a structure. If it is centrosymmetric, chi2 will vary. It can be proved by mathematics also. So, but when you are working on liquid samples, the fast nonlinear. Now, like any material will have a refractive index. So that is your linear refractive index. But in presence of high intensity light, this will be modified. You get an additional another refractive index called the N2. That is the nonlinear refractive index. So this one is correspond to your delta N. That is what is your additional you are getting at a high intensity. That is which is intensity dependent. And these properties which we are going to focus into detect is the biofluorescence. So this nonlinear refraction basically depends upon the size of this N2. So that is due to either self-focusing effect or defocusing effect. Well, I will explain what it is. Similarly, the nonlinear absorption is due to either reverse saturable absorption or saturable absorption, either the beta could be positive or negative. So let's explain what is self-focusing. So what happens in this light matter interaction? Because there is a pattern of intensity here, high at the center and then gradually decreases both sides, because this is the shape of the light. Therefore, you see this N2 which is intensity dependent, so you will get high N2 if it is N2 is positive at the center and then it reduces. So therefore, there is a process of when the wave fronts are traveling inside the medium, they will try to converge it. Because at the center, the wave front will travel slower and here it is faster. So therefore it will converge. So you see this much beam diameter now converges to a very tiny spot, and this principle is called self-focusing. Exactly opposite will take place in case of self-defocusing. Your beam diameter will be diverged, it will be bigger. So these are the two principles which will use it to study the nonlinear refraction properties of any material. So similarly, the nonlinear absorption can be explained in a very simple energy level diagram. So if you have studied this atomic and molecular spectroscopy course, then you can connect this. So we all love that all molecules stay in the ground state, and then when the light shines the material, some of the molecules will go to the excited state, and then after some time they will come down to the ground state. And this process you can explain with a simple transmission equation, like light pass through, something is absorbed, something is transmitted. This is the way how you understand mathematically. And then these n's are the population of different states. So if this process will continue, what will happen? Now there is a chance that possibility of 50-50 population will take place. That means if I am measuring transmittance, I get 100%. There is nothing absorbed because the population of the two level is equal. Therefore, you get a flat line, and this condition is known as saturable absorption. Similarly, like if you have high intensity photons that can trap these molecules even further high, then again the transmission intensity will go down, and this condition is known as R.I.H.S, and it is because of the excited state absorption. So there is also a chance that simultaneously these molecules can directly go to this state, and this is a quantum mechanical phenomena explained by a multiphoton process. Okay, so this is also possible. So this can also give me a condition or the effect called reverse saturable absorption. So here I will tell you this technique is such a simple one. So even without going the complicated data analysis, by just seeing the data what we are observing by eye, we can predict many things. For example, the signature of N2 and signature of beta will tell us whether what kind of effect we are going through, the self-focusing or defocusing, saturable absorption or reverse saturable absorption. So I will tell you the typical profiles here. So when you are scanning, so you see in case of self-focusing, you get a profile like this when you are measuring transmission as a function of position. Similarly, if you have self-defocusing, you will get a peak and then a valley. So exactly opposite in nature. Okay. So I don't have much time, otherwise I could have explained you the physics behind it, how this is happening. Okay. Next. So similarly, what happens is we are talking about that we are blocking completely the absorption part when we are focusing on the refraction part. But like nature is more powerful than us. Our like the technology is what we are creating. Therefore, always there will be some leakage. So the absorption information can also come while measuring the refraction. So in that case, what will happen? Suppose you have a contribution of sensorial absorption in your profile, so it will enhance the peak and suppress this valley. Similarly, when you have a contribution of R.I.H.S, what will happen? It will suppress the peak and enhance the valley. So such type of signatures you can also get if your signal is not pure for only refraction. Okay. Similarly, in case of open aperture G-sun signatures, it is very straightforward. If you have a essay, look at me please. If you have essay, click. If you have an essay, you get a simple big profile, or if you have a R.I.H.S, you get a exactly opposite valley profile. Okay. So, but again, there could be also a combination of these two, because what is happening in the molecular level, we don't have any control, right? We just shine light. So they take their own action. So therefore, there could be also combination of these. So if you have a combination of R.I.H.S and S.A, so what you will see is in the peak you will get a valley also. This kind of profile also you will get. Similarly, if you have a S.A in R.I.H.S, you will get a valley, then a peak at the center, and so this kind of double signal signatures also you can get it. So therefore, when you see the recording data, don't worry that we are doing something wrong. So these are ideal cases, but these are the actual cases. Sometimes you get the signature of both. So like that, like these are just the raw information. You can also go detailed data analysis. So there are different models called Everett thermal lens model, because we are measuring transmission as a function of Z. So this equation we can use it. There are also models proposed by Zach because it's running from last 40 years. So for open aperture G-sun, we can use for purity signal, we can use this, or for mixing signal, we can use this equation. And then for data analysis of N2, beta, and the susceptibility, what I showed you, like we need to measure this nonlinear refraction parameter N2, absorption parameter beta, and the I3, the nonlinear susceptibility. These are the parameters we will connect for sensing these biomolecules. So this is just the laser protocol, like how much wavelength we use, how much laser power we are using. So this is a little bit technical, so please keep this. So now we'll bring to the first one, how we are going to sense hemoglobin blood groups. Okay. So first we need to analyze our molecule. The first analysis is always done by taking a simple absorption spectrum. Okay. You take the absorption spectrum of that molecule or the protein and see where in which energy level they are absorbing light. So this is the information you can get it. So you get a peak at 405 and you also get a peak around 270 nanometer. And what wavelength we are working is at 532 nanometer, where you see there is not much absorption. So we know that, okay, where are the resonant conditions for this molecule and where exactly we are working. And so when you perform the CAG scan for the pure hemoglobin, so first we have tested that whether hemoglobin is showing nonlinear signal or not, that we need to test before going in the blood cell. So first we have tested that and we saw that hemoglobin is giving us nice the nonlinear signals, and from this we can say this is self-defocusing effect. And there is another way that you can measure simply. If you don't want to perform the detailed data analysis, there are empirical ways to calculate this N2 also. So you just measure this peak to value difference, that is called delta T minus V. So what we have observed here, when you are increasing the concentration, there is a unique delta T minus value at each concentration. And we use this empirical formula to find out N2. So you see that we got the different concentration of hemoglobin, we got different magnitude of the values, and it clearly shows that as we are increasing the hemoglobin concentration, these non-linear magnitudes are also increasing. Therefore, with an increase in HB concentration, what we saw, the non-linear signals are also increasing, and we correlated this and we found out there is a very nice straight line correlation between these two. So the linear correlation is established with this N2 value at HB concentration. So therefore, we know now that okay, we have this graph. Then what we have done, we took 3 blind samples where we randomly prepared the sample, but we don't know the concentration. Okay, but even if you know, you hide it, pretend that you don't know it. Okay, so then you perform the experiment and measure the N2 value and put it here. And for each one, you can see they are falling on the straight line, and will give you will give you each values of 1 each. So 1 each it will give you. So but now we compare this with whatever the value we have hidden before, and what we saw here. This is the value measured by our technique, and this is the actual concentration what previously prepared. We know that. So we can say that there is an excellent match between these numbers, and hence we can conclude that we have successfully estimated the unknown hemoglobin concentration by using this clean optical technology. Okay. So now this one we have tested in human blood. Like this is the practical application of this technique what we are talking about. So we have taken volunteers, we have donated blood, and we have done this with many patients with different blood groups. So we have how many blood groups we have? 4, not 5. 4 blood groups. Okay, A, B, O. Each will have R.H.S vector positive and negative. Okay, total 8. Like if I bring the R.H.S vector. So we have taken 8 groups here, and lot of samples have been taken. And what we have table in each blood group, what you saw is like a increasing trend with respect to increase in the hemoglobin level. So what we conclude again, with an increase in HB concentration, the N2 value increases irrespective of the blood. That means it is exactly following the way it followed in the liquid sample, just like when we done pure hemoglobin. So we have, so to understand it, what we have done, now we have taken a particular group, like O positive blood group. So then we have performed the experiment, we have calculated the data, and thus summarized here. And what we observed, the same trend again. And so with increase in HB concentration, again the N2 increases with even a single product. So that was the overall conclusion we made. Now we will go back. So we will again correlate the same graph, which will follow a straight line, and then we have gone with the unknown HB concentration. Now we have taken O positive blood of 3 patients, let's say. Then we measured already, like those values are hidden. Now we have tested our technique. So we got the signals, and then values keep on going. So what you see here, keep on going. So what you see here is the values obtained from our technique for, because of this N2 values measured from here. So we can say that again we see a very good match between these two, because these are the measured values by CA technique. Then we use a autohematology analyzer, because that is the instrument used in the pathology centers to give you the hemoglobin level. So we have successfully estimated the unknown hemoglobin concentration in O positive blood group here, which is tested. So this technique we have patented. We got the Indian patent that we can use without using any chemicals. By a simple optical technology, we can use this kind of technique to measure hemoglobin. And this is also, if anyone is interested, you can see. This is also published in the Journal of Applied Physics. So this can as a hemoglobin sensor, a simple and sensitive optical tool for measuring hemoglobin concentration in human blood. Okay, so this is a clean technology without using any chemicals. So similarly, we have done, because the results will be exactly similar what we have done here. So I will go a little faster to save the time for other speakers. So we have in a medical function or in a pathological setup called the urine. So how we have done it? We have prepared artificial urine in the lab to test this. Just like we have taken blood from volunteers, we have prepared artificial urine in the laboratory to test whether we can detect or not. Because if we are getting urine in the muscle damage, the muscle could have damage in the heart or any part of the body. So that is a serious condition, because that can lead to even heart attack. So this is a very good test of detecting myoglobin in urine. So I'll just go ahead. So this is the normal characterization of myoglobin. Go ahead. So as previously we have tested this with the pure myoglobin sample in a solution, the previous buffer. So you purchase this and do it. Good. So what we saw here, the PBS did not give any signal. That is a good sign, because the solvent what we are using that should not give any nonlinear signal. Otherwise your main signal will be corrupt. So then we got the signal, and what the effect we got is self-defocusing. As you see here, I told you that sometimes you will get absorption contribution in the nonlinear refraction. Exactly, this is the example I wanted to show you here. The peak one is greater than the valley here, so it is a condition of censorable absorption effect, and that also can be confirmed by using a open aperture disc-scan, because we know that open aperture is purely responsible for nonlinear absorption samples. So you get this signal and correlate that. Okay, we have saturation effect. Next, so you use this model, because the model is used to fit the data in detail. Previous project I showed you empirically also you can do it, because I have to give two examples. You can go for rigorous data analysis, or you can do with the empirical one. So same thing we have observed here. You can see that the absorption parameter what you get from open aperture or closed aperture, they are closely matching, so it doesn't matter. So what we see, both the refraction and absorption values they decrease by decreasing the MB concentration, and the magnitude of MB nonlinearity also concentration dependent, and that's what we have used it. You can see they also follow the straight line path. It is a linear correlation between both the refractive and absorptive values as a function of concentration. And now we exactly test this in artificial urine. Like we will see whether we are detecting it in urine or not. So you can just see, when you take only urine, there is no signal here. The moment you add myoglobin there, the signal starts coming. So we have gone up to the lowest of 8 micromolar. So no signal for artificial urine, just keep on going. Okay. Again you have the effect of keep on going. Saturation in the case of hemoglobin, and in artificial urine in the case of myoglobin. Early disease diagnosis, because this is one of the key words what we need to understand. Any disease could be curable if it is detected at the early stage. So if you are able to detect these parameters like lowest to lowest concentration, that means that implies to the early condition. So it is successfully sensed it. Therefore, all these early diagnosis of diseases related to the imbalance of heme proteins can be diagnosed by using this tool what we have developed in the lab. So this tool, therefore, not only for these parameters, it can be also extended to any biological parameters related to any human disease, and that it will be helpful for the sustainability of a healthy human life. So I would like to thank the funding agency SCRP and the DST, and like to thank Dr. Sunil Kumar Verma. He is a doctor in R.I.H.S Hospital who actually helped us for supplying the blood samples and in biological projects. And I would like to thank our lab and the student who did this two projects is we have actually submitted the thesis now, and two of my students So thank you. You have any happy to.
Thank you, Mr. Tripathi, for starting from brief introduction to non-linear optics, where our students will be benefited because in higher study they will study about the non-linear optics. If you have any question, one or maximum two questions. We are running late.
Anything into disease related also you
If
can
we
ask.
are not asking any question now, during lunch time we can interact with Professor Tripathi. Thank you, sir.
Thank you.
Then our next speaker, Professor Santosh Kumar Agarwal, Bhograi University Valley. Sir, he will deliver the lecture on need of radial sensitivity for analyzing the elastic scattering results. Start.
First of all, I would like to thank the organizer for giving me a chance to speak something in front of the students. So this talk specifically for the students, not for the researcher in the first line. I want to know something because the organizer also allowed me to speak in Odia. Okay. ଆମେ ସବୁ ଫିଜିକ୍ସ ଷ୍ଟୁଡେଣ୍ଟ ବୋଲି ଆମେ ଜାଣେ ତାର ପଚାରିଥିଲେ ପୂର୍ବରୁ ତେଣୁ ଫିଜିକ୍ସ ଷ୍ଟୁଡେଣ୍ଟ ହିସାବରେ ଆମେ ମୁଁ ଭାବୁଛି ନ୍ୟୁକ୍ଲିୟର ଫିଜିକ୍ସ ପଢ଼ାଇନି କରେକ୍ଟ ମୋର ଟପ୍ ପୂର୍ବରୁ ଦୁଇ ଦୁଇଟା କ୍ୱେଶ୍ଚିନ୍ ପଚାରେ ମୁଁ ମଧ୍ୟ ତଳକୁ ଯିବି କାରଣ ମୁଁ ଟପ୍ଟା ଅଲଗା ୱେରେ ଯିବି ଏବେ ସାର୍ କହିଲେ ପୁରା ରିସର୍ଚ୍ଚ ବିଷୟରେ ତା ପୂର୍ବରୁ ବି ସାର୍ ମାନେ ରିସର୍ଚ୍ଚ କରିଛନ୍ତି ଆଇ ନୋ ବଲ୍ଟା ବାଉନ୍ସ ହେଇସାରିଛି नहीं आमे ठिया है सब ऊपर जाइए करेक्ट सेति मध्ये किछि निजे मध्ये ढोळै जंती किछि फोन ने एंगेज होचंती किछि देखु जंती किछि देखि पारु नांती लिनियर करेक्ट ता भितरे मु खाली पचारे को चाहूची न्यूक्लियर फिजिक्स पढिछ ना न्यूक्लियस विषय पढिछ करेक्ट तो मोर गोटे क्वेश्चन हला हाउ टू मेजर द साइज ऑफ न्यूक्लियस और साइज ऑफ एटम सिंपल क्वेश्चन मतलब गोटे न्यूक्लियस को होचे आई नो द साइज ऑफ द न्यूक्लियस आई नो द साइज ऑफ एटम मो मन में स्ट्राइक करेगा था हाउ टू मेजर द साइज ऑफ न्यूक्लियस और साइज ऑफ एटम साइज केते के कोई पे साइज ऑफ द न्यूक्लियस एनीवन एनीवन के कोई पे एटॉमिक साइज केते कहले खाया मिलुनी मु तमरी यूनिवर्सिटी रो आसी मु बाहर लोक नु बी कैलकुलेट करते साइज ऑफ द एटम और साइज ऑफ द न्यूक्लियस एनीवन
This size of nucleus is 10 to the minus 15 meter.
Very good. For meters. Correct. A size of the atom angstrom. Correct. तेणु गोटे ला 10 to the power minus 15 आ गोटे लेटर से 10 to the power minus 10. Correct. 10 to the power minus 15 के केतेटा शून्य पड़छिलो डेसिमल 15. आमे जिबा त 14 के 15टा शून्य मारिले कैलकुलेटर व्हाट इट इज 0 वो बात है कि कैलकुलेटर আছে if I can go for the measurement it should be 0. Now question is that how to measure the size of the nucleus or size of the atom in lab. What लुहा बॉल दिया है think about the plus 2 practical how to measure the size of the ball who instrument they use for you know very good screw work correct आमे screw कहते तारा diameter किबा radius measure करथले nucleus is also spherical तो मु जाव पॉइंट atom also spherical can you use fugers to measure the size ताहे केमती मेजर हेतिला आमुक तो मास्टर कहले 10 to the power minus 15 सार कहले 10 to the power minus 8 so how you can measure मु जिबी मो टॉपिक को जिबी 5 मिनिट साथे तला मु बाउंसर पकेनी व्यस्त हो हला को 10 to the power minus 15 10 to the power minus 5 8 बट केमती हमें मेजर कर আমি কেউ চিন্তা করেছি? Because now I am talking about a topic which is related to the nuclear physics. If I do not know how to measure the properties of the nucleus, then it is very difficult to go into the research in nuclear physics. Everybody is talking about electron, everybody is talking about atom, but it is better to know how to measure the properties of the nucleus. So the best way to measure the property of the nucleus or property of the atom, it is the scattering experiment. Correct? So when you go for any scattering experiment, what is scattering experiment? What are the major things? You need a target, you need a projectile. You heard about that one, correct? So you need a projectile beam. The projectile beam must strike the target. Target may be at rest or in motion. And this effect of this scattering is calculated, or you can say collected at the detector. So there are three main things. One is projectile beam, second one is target, third one is the detector. So the information at the detector must be. So this is the way we are measuring the size of the nucleus or size of the elementary particles. So what I want to convey, that is the scattering experiment is the main tool to find out the property of the elementary particle or property of the nucleus. Correct? So my topic is need of radial sensitivity. Don't bother about that one. For analyzing elastic static measure. So one word is scattering. Now you know what is scattering and what is the role of the scattering in my talk. Okay. So this is one of the major experiment or major thing we have to do to find out the properties of the elementary particle. Correct? Then let us think about a projectile beam is your nucleus and your target is a nucleus. Okay. It is very interesting. Both are the size of 10 to the power minus 15. You are dealing with the beam, the particles having 10 to the power minus 15, and the target also it is very thin. Almost we can say both are invisible. But you are trying to find out the results of the detector. Correct? So the experiment must be taken care by the large set of and many I can say there are many financial constraints are there. But when the nucleus collide, what are the forces, or we can say what are the forces involved in that? I mean, ketita elementary fundamental forces and anyone? Ketita fundamental forces and gravitational force, electromagnetic force, nuclear force, then weak force. There are four fundamental forces. What do you mean by these fundamental forces? Professor Sundar will tell regarding all details of this fundamental forces, I think. So these fundamental forces means whatever seen in the nature, all forces must be derived from these four forces. Correct? আমি সেটা ভাবে আমার আউ সবগুলো derived one. Do you know about fundamental unit and derived unit? Like that, you can say it is the fundamental forces and the derived forces. Out of these fundamental forces, if you see gravitational force from mathematical law of energy. Correct? It is written in the book. Electromagnetic force or Coulomb force from mathematical law of energy. 1 by r power gravitational force is 1 by r square power. Then weak force, forget about that one. Do you have any mathematical form of the nuclear force? Nuclear force from mathematical form of it. Bohine. Kahin पढ़ा? There is a question mark. Is there is no mathematical form of this nuclear force? The answer is the nucleus is completed. When you jump from one nucleus to another nucleus, their behavior drastically changes. Correct? When you go from one nucleus to another nucleus, the behavior drastically changes. So it is very difficult to get a universal mathematical form of the nucleus. Correct? But still people are working for a universal formula for the mathematical force, or you can write a code with taking into all the property of the nucleus. Correct? So that is one question in mind. So that is one question in my mind when I was sitting in front chair. Okay. When return back to the nucleus scattering, then nucleus scatter करिबो by interact करिवे केते प्रकार force involve हो anyone केते प्रकार force one is nucleus is a charge body so Coulomb force must be there. Second one, nuclear force must be there. Nucleus centrifugal force. Do you know about centrifugal force? Do you know about centrifugal force? अरे physics पढ़ुଛ तो doubt physics पढ़ुछ तो centrifugal force को centrifugal force बहुत ही सुनी जगह. Okay, so this is not a real force. I can say centrifugal force is not a real force. It is due to the rotational degree of freedom. Like comes into the picture. If a particle rotates or it has some rotational degree of freedom, okay, then the centrifugal force comes into the picture. So there are three forces which are mainly taken into care during nucleus collision. So there is effective force which is coming into the place. Nucleus consists of the nucleus, so it is a many-body interaction. But when you go for the analysis of many-body interaction, you need complicated mathematics. What we have done a phenomenological approach, that means reducing this many-body problem into two-body and using the semi-classical theory, whatever you are going to study in quantum mechanics and non-electricity or electricity, we are going to use that one to find out some result related to this nucleus current. Okay. So already I introduced the topic. Then it is called as heavier. Nucleus is a ion. In chemistry language, I can say nucleus is a ion. Why? If you remove the electrons, the nucleus is definitely ion. So that is why when you say heavy collision, it represents the nucleus collision. Heavy means A greater than 4 is called as heavy. Lighter means that केवल hydrogen and helium पता है. All other ions are considered as the heavy ion nucleus. Then optical model potential. Here, instead of talking about the force directly, we are talking about the potential. The potential represents the force. So when I say nuclear potential, you must think about the nuclear interaction. When I say the Coulomb potential, so you think about the Coulomb interaction. So the potential is the representation of the force. What is optical model? The force is real. Whatever we say, gravitational force, Coulomb force, or nuclear force, all forces are real. But if you include one force, I cannot say force, when you include a potential in complex form, what will be the result? Do you know about the conservation principle? Correct? Equation of continuity. Del dot J is equal to 0. Forget about del rho by del T. Del dot J is equal to 0. Divergence of Z is 0. Indicates that it conserves the flux. The net inward flux is equal to the net outward flux. Correct? If it is less than, then it acts like a sink. If it is greater than, it acts like a source. Is it correct? Now, the del dot J is equal to 0 can be analyzed by using the real potential. Means if the potential is real, it is possible to analyze by the real the del dot J 0. But what about del dot J less than 0 and del dot J greater than 0? It can be analyzed with the help of complex potential. If you make the potential complex, that can be analyzed. So the use of complex algebra, complex calculus is coming into the picture in physics. So this optical model is nothing but the use of complex potential in case of nucleus. So here we are modifying the nuclear force or potential into complex form, and that complex form take care the loss of particles during the static. I am not talking about the creation of particles. Then sensitivity and let me cover all these slides and automatically the sensitivity come into the picture. Then there is a loss technique, it is related to some research work. Then conclusion means my research outcome. Already I talked about the heavy ion. Nucleus has the heavy ion has some basic property, large electric charge, it is big size and large mass, and all these properties leads to the strong Coulomb interaction, strong large orbital angular momentum, then strong action. Why I am saying this property leads to the semi-classical approach, because you know nucleus is a quantum system. Nucleus is a many-body particle system. So if we can go for the many-body system or quantum application, it needs high computation or high analytical approach. So in order to get the first hand result, we have to use our basic knowledge. So in order to use the basic knowledge, you must think about the system is equivalent to semi-classical approach. So this property makes the system semi-classical. So next. Then depending upon the incident energy, this is the beam energy, there are three regions. One is the low and medium region, where low is 0 to 10, intermediate is 4 to 30 MeV. Then high is 1 GeV, that is where you can analyze the QVP. But in my research area, this is mainly low energy region. That means I am talking about 0 to 10 MeV per million energy. Already I talked about the nucleus in the many-body system. We need a phenomenological complex potential in order to highlight the loss of the flux in the static. Then the complex potential, why it is optical? Because it is equivalent to complex refractive index in optics. So that is why this potential is called as the optical potential. Complex refractive index also indicates the loss of rays when the ray passes through the medium. If the medium is treated as the complex, then it leads to the absorption of the ray. So in the similar fashion, we are considering the potential is complex, and when the beam enters into that region, it leads to the absorption. So that is why this potential is named as the optical potential. Then already I am talking about Already I am talking about this beam technique. It is the B nucleus, B Coulomb, and B centrifugal. And this is a simple equation. You know, this is a single particle potential equation. It is coming from two-body interaction. And this equation is possible. It is possible to reduce two-body problem into one body, and the interaction with the central potential. Central means the potential only depends upon R. In 3 dimensions, it is R theta phi. If it only depends upon the magnitude of R, then it is called as the central potential. The separation distance between the two points. Next. Coulomb potential, it is the general form of the Coulomb potential. What we have written here. Centrifugal, L into L plus 1 H plus 1, this is the form of the centrifugal potential. This nuclear potential, it is quite interesting because already I told you there is no universal form of the nuclear potential. So you have the many options. Taking into the properties of the nucleus, you can go for the various forms of the nuclear potential. So we have used a potential. This is our group. We have used a potential, that is the Vinozul potential. It has two parameters, mu and lambda. And by considering some specific parameter, we have modified the nuclear potential like this form, VA. And there are various parameters because I know this is the complex, the nucleus is complex one, and the potential interaction is also complex. So the definitely the potential depends upon the many parameters which can take care of many form of this potential. Next. You see, these are this is the plot of the real potential, nuclear potential, and this is the imaginary part. And this one, most interesting one is here we have taken the two parts. One is the surface nuclear part, and second one is the volume part. The surface effect of the nucleus is very important. Many processes, many reactions are possible to. I can say you can analyze many processes with the help of Similarly, the volume part is separated from the surface. That is why this potential is a versatile potential. We can control the surface and volume as per our requirement. Next. These are the, I can say, these are the output parameters required for the scattering experiment, starting from scattering cross section and elastic structure EL. Then it is also related to the fusion process. In your higher studies, you are going to study the particle wave analysis, and that particle wave analysis gives you the result of scattering cross section, and as well as the correlation with the each wave of the scattering cross section. Okay, another one question. What is scattering cross section? Anyone? Please. It is simpler. Forget about the unit dimension. What I mean scattering cross section. Let us think about the outward flux by input flux by incident flux. That ratio gives you the scattering cross section. Simple. Forget about the unit. The outgoing flux by the incident flux gives you the scattering cross section. It is the definition for, I can say, the experimental. Theoretically, you have to calculate by using, you can say, the Schrodinger equation and kind of relation. Then the need of sensitivity, that is important. I can say the exact form of the nuclear potential is not known. So many scientists, many groups have used many potentials, starting from the root section potential, modified root section potential, LC potential, Gaussian potential, in our group, Pinocchio potential, Ricard potential, Morse potential. So many theoreticians have used many potentials in order to explain the experimental result. So you are getting a many set of parameters. Question arises which potential is suitable and which parameter set is suitable. Because I am going to flip the data and I am able to publish a paper in international journal. So it is accepted, yes, this potential is good. The same system is explained by another group with another set of parameters. Okay, and it is also possible to find out the same result with the same potential with a different set of parameters. So now question arises, which set is correct for this potential or which potential is physically acceptable. So that is coming into the sensitivity mainly is the answer of this one. So we are trying to find out the answer of that, then how to check the physically acceptable set of that nuclear potential. Which potential and which set of parameters actually physically acceptable. Next. Then we go and think to what I told that is reflected in a paper, and it is there that the ego arbitration because many sets are there and which set is acceptable. The Morse technique means we have a potential theoretically because I am talking about nucleus interaction. If you try to break the potential at each one, that means suddenly the potential jumps to zero. That means at each point I am making a zero line. Then definitely the result will be affected. Whatever we are going to explain, the result will be affected. So the force strain must be continuous. If you make a discontinuity at each point, then gradually the result is affected. But it is quite interesting if you make the discontinuity at insensitive region. What is the insensitive region? Theoretically I can say where the results are not affected, making it top. Right? When you make the potential suddenly zero at some point, immediately the results are not affected. I can go for the checking at each point and I find the certain region of the potential which is drastically changes the result. So we mark that region as the sensitive region for the potential. Why? Those parameters we have chosen for the potential, if the set is affect that sensitivity region, then definitely that set is acceptable for the calculation or that set is acceptable for the nucleus color. Right? So constant is sensitivity there. We have also kind of I can say perturbation. So we can make perturbation. This perturbation gives you the different errors. So I can show you a chi-square graph. Next. See, this is a chi-square error calculation. I don't know. That is a chi-square case is there. Do you know or not? So actually, the chi-square means the experimental and theoretical difference, and divided by the experimental result. So this chi-square, you think about the difference between the observable and experimental. Here you see the almost the difference is zero in this way. But here it suddenly jumps. Means we are unable to read the line. So I can mark this 8 line what we are is the sensitivity region. And if you change the parameter, if it affects that region, then that is called as the sensitivity. So this sensitivity checking helps us to find out the correct nuclear potential to explain the elastic. Next. So I can analyze any system. We can. So like F19 and 208. These are the chi-square test, and we are able to find out the sensitivity. Okay. This is also the example. Okay. Okay. Yes. The what are the sensitivities are explicitly determined for the system. Then when things are obtained from the direct static question, then there are many small things that you have already done. That is due to mass and interference. Potential from sensitive are non-linear nature, very joining from the surface to volume, and that point of joining is the sensitive region actually in our body. Okay. So these are few other concepts related to that. Okay. These are the elastic analysis. You see the error splitting by taking appropriate set of analysis, set of parameters. Okay. So what is the takeaway from my talk? First takeaway: the experiment scattering is required to know the properties of the elementary particles of nucleus. And for the scattering experiment, it is possible to reduce the many-body problem to two-body problem. Third one, the nuclear potential. Till now, we don't have any universal shape of the nuclear potential. So we have to work for the mathematical formulation of the nuclear potential. Fourth one, the complex potential leads to the absorption, means the loss of particles, and that complex potential in nucleus is called as the optical potential. That's all for it. So thank you. Any question?
Thank you, Professor Agrawal, for your nice talk about the nuclear potential and its applicability. Any question? One or maximum two. We are running very late. If no more questions, let us thank Professor Agrawal for his nice talk. Thank you, sir.
Department of Physics, National Institute of Technology, Durgapur, West Bengal, India, to deliver his talk.
Hello. Good afternoon, all. respected speakers, today and established speakers, staff and faculties of R.I.H.S BHOGRAI, and beloved students. I thank Vijay Kumar Mishra, the principal, this institute, for inviting me to deliver a lecture in this seminar. My special thanks to Dr. Kamal Kumar Konda and his teams, due to whom I am here to spend some time. And my talk basically that recent advances in higher energy physics. It is for our students. I will start from the fundamentals. First talking fundamental courses, and their education already Professor Agrawal has mentioned there are 4 fundamental courses in the lecture. I think our students, those who are present, they are reading about fundamental course. Anybody who can say what do you mean fundamental course? Anyone? Since we are running very late, then I can discuss. The fundamental particles, I think you have read fundamental particles. Fundamental particles are those particles whose internal structure cannot be expressed in terms of other particles. But other particles can be expressed in terms of these fundamental particles. Similarly, fundamental force is a mechanism or a force by which particles interact with each other and which cannot be explained in terms of other forces. There are 4 types of fundamental forces in the nature. The gravitational force. Due to gravitational force is responsible for the gravity which binds us to the surface of the earth. At the larger scale, we can say that planets in the solar system and stars in the galaxy and galaxies in the universe. I think our students already know, or they have read from different books. In our galaxy, so in our universe, there are approximately 10 to the power 11 number of galaxies like Milky Way, and there are 11 number of stars like Sun in our galaxy. So we can say that approximately 10 to the power 22 number of stars like Sun are present in our universe. There is the concept of a multiverse. Beyond our universe, maybe other universe present, this universe. So how large is our universe? But this large structure of the universe is basically due to this gravitational force. Then electromagnetic force, I think already Professor Agrawal has discussed this thing. So due to this electromagnetic force, electron is bound in the nucleus, Then weak nuclear force is basically acts in the atomic scale. For example, beta decay, where a neutron decays into proton, electron and electron type neutrino. Then strong nuclear force, that is quarks are bound inside the protons and neutrons. Later on we can say that these protons and neutrons inside the nucleus are bound by this strong force. Here you can see that fundamental state. I have arranged the fundamental forces according to their strength. If we consider the strength of a strong force as 1, then electromagnetic force 10 to the power minus 2 and weak force 10 to the power minus 12. Gravitational force is 10 to the power minus 39. You can see from this data, it is clear that strong force is the strongest and gravitational force is the weakest fundamental force. Although it is the weakest fundamental force, but it is responsible for the large structure of the universe. And the fundamental forces are, for each fundamental forces there are intermediate particles or linear forces. For strong force players, electromagnetic photon, and weak force document Z0, and gravitational force graviton. Although we are staying in our universe, but we don't know what is the origin and evolution of our universe. There are many theories, but the most acceptable theory is Big Bang model. According to Big Bang model, when the universe was created, at that time 4 fundamental As time passes on, temperature decreases and some phenomena occurs. As a result, from this unified force, first gravitational force is separate at the time 10 to the power minus 40 milliseconds. That is the Planck cycle. Again, as time passes on at 10 to the power minus 35 seconds. From this unification, strong force is separate. So from that time we are getting three forces. One is the gravitational, then strong, another is the electromagnetic force. Similarly, at 10 to the power minus 11 seconds after the Big Bang, the splitting of electronic force occurs as a result. From that time, we are getting four fundamental forces in the universe. Since at that time, there were four forces, all were unified. That is why the scientists are trying to unify all the fundamental forces and to see what was the condition of the universe at that time. But so far, the physicists are able to unify only three out of four fundamental forces. Except the gravitational force, all the three forces are unified. The unified description of these three forces is known as the Standard Model. And this Standard Model expresses the present understanding of known fundamental formulas, quarks, leptons, and forces between the electromagnetic force, weak force, and strong force. This model is also known as quark-lepton model. And here the quarks have 6 quarks and 6 leptons are there. Quarks have unusual characteristics. Before the discovery of quarks, the charge of all particles were expressed integral multiple of the E, that is the fundamental charge of particles. But after the discovery of quarks, it is found that these quarks have fractional charges, 1/3 or 2/3 E, that is the charge of it. Similarly, quarks also carry another type of charge which is known as color charge, red, blue and green. You will see that 6 quarks in the first generation up, down, charge, strength, top, bottom. Similarly, electron type, muon type, tau, and the first generation quarks and leptons are found in the ordinary matter, whereas the second and third generation quarks are found only in cosmic and accelerators. As we increase the number of the generation, then particle becomes heavier. For example, top quark is the heaviest quark among all the 6 quarks. Then we see the charge of the quarks 2/3, 2/3 and -1/3, -1/3, -1/3. So we can say that fractional charge. This is the elementary Standard Model of elementary particles. The quarks, up, down, charge, strength, top, bottom, and leptons, electron type neutron, muon type neutron, tau type neutron, and these are the intermediate particles or gauge bosons. Then you will see that there is another particle which is the Higgs boson, popularly known as the God particle. But because Higgs did not like that name as God particle. So Higgs boson, that is the last particle, and it is a special position in the periodic table of Standard Model of elementary particles because it has some special properties. That properties in the time they are going to discuss some of the properties. Then the drawbacks of the Standard Model. We know that in the universe there are 4 fundamental forces. Out of the 4, 3 are unified. That is why this unification is not complete. And in the Standard Model, only 3 out of the 4 fundamental forces are unified. That is why this Standard Model is popularly known as 3/4 of everything. In 2005, you will see this is a popular article which is published in Physics Education, which is for our college level students and PhD and MSc level students also. In that article, the alternative name for Standard Model I have given as 3/4 of everything. Why I have given as 3/4 of everything? If there existed a theory which would be able to unify all the fundamental forces, that theory will be called as theory of everything. If theory exists, then Standard Model will be called as 3/4 of everything. And there is one theory which is the string theory name I have given. That is the hypothetical or proposed theory. solving the equation of the string theory, it is found that the behavior of some particles are like leptons and some are like the gauge bosons, that is the intermediate particles. And after solving that equation of the string theory, it is found the behavior of some particles is like that of leptons. That is why it is expected that in addition to the three forces, the fourth one, that is the gravitational force, is present in the string theory. That is why string theory is one of the proposed candidates to be as a theory of motion. Then there are three generations as a first, second, third, why not more than 3 or less than 3? It cannot express about the existence of a dark matter and a dark energy in the universe. What we are able to see by our naked eye, using the accelerators, indicators, whatever the piece of our instruments of us. We are able to see only 5% of the universe. 95% of the universe we are not able to see. That is known as the darker side of the universe. Out of 95%, 68% is large energy and 27% is dark matter. But so far it is not explained of our standard model. Although standard model is the most successful theory to explain the phenomena existing in the universe, except the universe. So standard model cannot explain the matter-antimatter asymmetry. According to the standard model, where the Big Bang, at the time of the Big Bang, there were equal amount of matter and antimatter. But nowadays we are getting more matter than that of antimatter. This is known as matter-antimatter asymmetry, and this asymmetry is not explained in the standard model. Then, existence of massive, what I said, there are different types of neutrinos. Kiloton type neutrino, muon type neutrino, tau type neutrino. All are massless in the standard model. All are massless in the standard model. But recently, not very recently, I can say that more than 10 years before, it proves that it has some mass. So this existence of massive neutrino is not explained in the standard. These are few drawbacks of the standard model. Then unification. Maxwell unified electricity and magnetism, taking optics as integral part, which is known as electromagnetism. Then quantum theory of electromagnetism was formulated by Feynman's figure, which is known as quantum electrodynamics. That is the first relativistic quantum theory which explains the interaction of matter and light. Then, when heat interaction is unified with QED, that is the electromagnetic theory. So we can say that in electromagnetic theory, electromagnetic force as well as weak forces are unified. Then in analogous with that, the QED, that is the quantum theory of quantum interaction was constructed, which is known as quantum chromodynamics. So in quantum chromodynamics, we can say that strong interaction. So when quantum chromodynamics is unified with electromagnetic theory, that is the quantum chromodynamics is strong force, weak force, and electromagnetic force. That is the gravity unified theory. The simplest gravity unified theory is the standard model. But so far it is not, gravity is not unified. So when gravity will be unified with gravity unified theory, that will be the quantum gravity. So far it is not fully constructed. There are many theories which are proposed to be as quantum gravity, one of them is as string theory. Why string theory is not possible to detect so far? Actually, due to its extremely small size. Actually, the size of a string is of the order of 10 to the power minus 30 centimeter. But the powerful detector oscillator what are used in the laboratories in the world so far, they are able to detect only up to 10 to the power minus 16 or minus 17 centimeter. So according to R.I.H.S, even if in 2050 we are not able to detect this string in the laboratory. That is why it is not fully conclusively the proposed, it is a proposed theory for this. Then Higgs boson. Higgs boson is a particle, I think some of you have listened about that popular God particle which is mass to every particle. Then these things, discover these things one point is here, Higgs field is exactly same everywhere, whereas magnetic and gravitational field, they are very already. Professor Agarwal said that your gravitational force is equal to G1 and 2 divided by R square, and similar that electromagnetic force is equal to square law, and nuclear potential also, there are different types of potential. They are varied from place to place and time to time, but your Higgs field is exactly same everywhere. And even if space were to be empty, completely filled with the Higgs field, we will not notice it. Higgs field is like air was or like water to fish. When particles are moving in this uniform Higgs field, they change their velocity. That means they accelerate. That Higgs field exerts a certain amount of resistance to the particle. That gives the mass. Actually, there is one procedure which is known as Higgs mechanism. That mechanism, every particle is getting mass. Now, what will happen if Higgs field will suddenly disappear from this universe? Then everybody will be massless, then we will move with the velocity of light. That is why you see that it breaks the symmetry of the nature. I think that is required. That is the special character of Higgs field. It breaks the symmetry of nature. That is spontaneous symmetry that is Higgs mechanism and that gives mass to us. If Higgs field symmetry was not break, then we cannot make that Higgs mechanism and we are not getting mass. Then all particles will be massless. Then we will not be existing inside the universe. Nothing will be there except massless. Then properties are time constants. This Higgs boson actually discovered on 4th July 2012. That Switzerland agency Large Hadron Collider experiment at Switzerland Geneva. They discovered that the new emitter particle, which is known as Higgs-like particle, and it is confirmed on 14th March 2013, and mass is calculated as 155.5, around 155. And in 2006, we also calculated the mass around 150. The special character is that it is very like the standard model Higgs one. Actually, in the supersymmetric standard model, there are 5 component types. That is why it is not confirmed whether it is the standard model Higgs boson or other Higgs boson. But the properties which are analyzed so far, the properties are matched with standard model Higgs boson. Then comes to that Peter Higgs and Engler, who have got the Nobel Prize for this discovery of Higgs mechanism which provides mass. Then there are reported 3 papers what they have first, why they have got Nobel Prize. I am omitting these things. These are the 6 scientists that then comes to another that massive. Already I said that in the standard model neutrinos are massless, but discovery of a neutrino oscillation which shows that neutrinos have mass, and for this discovery Professor Kajita and Donald, they have got Nobel Prize in 2015 for the discovery of a neutrino oscillation which gives or provides that existence of massive. What they have done it's already accepted that I have to consider these things. Actually, there are some problems that solar neutrino problem and atmospheric problem. What I have said in 2-3 sentences. Actually, when we are considering the sun, solar fusion, your proton fused to helium and these type. The neutrino which are produced in the sun, they are basically kilotype. But when they are coming from the sun to the earth and reflected in the laboratory, it is found that what has the theoretical effect. What was here actually, it is found that in the laboratory we are getting what that is known as solar neutrino. Similarly, the atmosphere actually, these atmospheric neutrino are created as a consequence of the cosmic ray protons. And when these cosmic ray protons are coming to the earth, they are colliding with protons from that origin charged by CTA. You will see that this charged by you can decay into neon and neon type neutron. Again, this neon decays into electron and neon type neutron. So, and here we are going to 1 electron type neutron and 2 neon type neutron. So the resistance will be 2:1. But when experimental it is detected, it was 1:1. Then where is that missing? Due to that, I was telling you. Actually, these are the some experimental restrictions I have with these things. Actually, what happened when this atmospheric neutron or solar neutron, they are coming towards the earth, and we are detecting only way when they are coming from the sun or that neon decaying time. On the way, they are transferred from one form to another. How they are transferred intelligently? Here, I want to explain this so that transformation of neutron level from one form to another form. And they, the scientists, they have said that for this neutron oscillation, mass of that however time it will be, it should have some mass. Otherwise, oscillation is not possible. They have not been the calculations, quantum physics, etc. But what I and another professor, Manasi Gosar, professor of Regional Institute of Education, Bhubaneswar, we have tried to explain to our college students how it is published in Science Report. I think we cover about Science Report, a magazine, basically for school and college level students. We have used special theory of relativity. I think all of you have heard about special theory of relativity. There are relation between mass and speed and briefly explaining that E equal to mc square, that m0 divided by square root of 1 square root of 1 minus c square by c square. That relation, if you see that if a particle will be massless, then what will be E by gamma will be 0. If E by gamma will be 0, E cannot be 0, so we are getting 1 by gamma equal to 0. Then from this equation we are getting E equal to c. That is only massless particle which are moving with the velocity of light. If any particle has mass, then it cannot move with the velocity of light. So far we know no material particle can move with the velocity of light. Now comes to another speed and time. Here you will see that delta Tm this is equal to this delta Ts by I think our students who are present here, they have read this expression. And gamma delta Ts. Now we will consider what is that delta Ts is the proper time and delta Tm is the time interval on clock motion related to an object. Now consider the case of a photon. Photon is massless, you know. If the photon is massless, already we have seen for massless particle gamma will be infinity. If gamma will be infinity, if delta Ts is finite, we get delta equals infinite. What is the meaning of delta T infinite? According to that time dilation, in finite interval delta Ts will be oscillating to infinity. So delta Tm will be infinity. If infinity, what is the meaning of that one? This means someone at rest on the earth watching the photon fly by seeing its internal clock take infinitely long time between ticks and clocks. What is the meaning? This is that the photon's time passes infinitely slow, as if time stops for the photon. So we can say that photons are timeless. If the particle has zero mass, then we can say that it has timeless. That means they can travel for billions of years without passage of time or change. That means they have no change. So massless particle, timeless, and no changeless. We can like that. If any particle is massless, then we can say that changeless. That means photons are changeless as well as timeless. Everybody clear about this? Then comes to neutrino. If neutrino will be massless, then what will happen? It will be timeless and it will be changeless. Changeless means it cannot change from one level to another. Since experimentally it is already was produced from solar fusion, they are coming to the white, they are coming to the dark. They are only way they are converting or they are transferring your time to our time. That is why we are getting 1/3 of the theoretical calculated value of kilometer. So we can say that if neutrino is massless, then it cannot transfer to other part. That means it cannot oscillate. But already neutrino oscillation has proved. That is why what we assume, if we assume that neutrino is massless, then we say that it is changeless. Since it changes its form from one form to another form, that is why it cannot be massless. So it has some mass, however time. What is the utility of this massive neutrino? It may be considered as one of the candidates for dark matter. So far that no candidate is confirmed for this dark matter. Small neutrino masses will be sensitive for the new physics because in the standard model, neutrinos are massless. If we improve the mass to the neutrino, then that phenomenon will be here. So this, although this standard model is very successful to explain some phenomena, also the existence of massive neutrino is one of the secrets of new physics beyond the standard model. That is outstanding. How do the neutrinos get mass? Already I said that Higgs boson is providing mass, but so far it is not confirmed whether from where these neutrinos are getting mass, whether Higgs boson or there are some other mechanisms, some mechanisms, etc. It is not confirmed. So what is the origin of a neutrino mass? Our students who are present here, I hope in future, while many of them, they will be on this type of work, they will give the answer of this. Then what are the absolute masses of neutrino? There are 3 types of neutrino, neutron type, muon type, and half type neutrino. What is the absolute mass of these? Till now it is not predicted, but the values of a neutrino mass square difference are known. Then what is the fundamental nature of a neutrino? Majorana or Dirac. Majorana neutrinos are both neutrinos which are the same antiparticle. That is, whether neutrino has the same antiparticle or it has antiparticle. It is not answered so far. The proposed neutronless beta decay experiment, we hope from that we will get the answer. Then, are there 4 neutrinos? Actually, only there are 3 types of neutrino, or there are 4 types of neutrino. Part of the proposed neutrino is sterile behavior is different from this one, but so far we have not confirmed. Then, why are neutrinos light and neutral? Can we observe equivalence in the electronic sector? These are the outstanding questions. I hope our students will take questions in future and will try to solve them. So these neutrinos have continued to provide information regarding the structure formation of the early universe, solar and supernova physics, nuclear properties, rare leakage of a charge and electron particles. So the study of this neutrino physics together with that it combines with that particle physics, nuclear and astrophysics to correspond. So we have no doubt that we are doing the exact proof of that. Thank you. Questions?
According to relativity, the mass changes with speed. So, for example, my weight is 65 kg. So, if I am moving one speeder, let's suppose in the one speeder according to the speed of light, so my mass will keep on increasing, right? And if I reach the speed of light, then my mass should be up to infinity. Then, if you are saying that neutrino have a finite mass, then if it is moving at the speed of light, then it's not Did I get it wrong?
That will explain the quantum mechanical phenomenon. That they have energy, momentum, like your bottom. We are saying that if it is massless, it is associated with energy and momentum. If you have a that one we can do.
Thank you.
Any other?
Just a comment. Mass, rest mass is always same. So whatever changes in invariant mass, that is effective mass invariant mass. So that changes. So why mass is zero for momentum for a long range interaction, and for short range interaction also massive particles are there, force particle, there is no answer. Rest mass is always
That is relativistic mass. That is why we say E equal to m system. That m is relativistic mass. That is why we say gamma m0 system. That gamma is the m0 is relative.
Thank you, sir. Now I request our Honorable Principal, Professor Vijay Kumar Misra, to come onto the stage and offer memento, trio and souvenir to our dignitaries. Now I request Professor Dr. Sukadev Sahu, Department of Physics, National Institute of Technology, Durgapur, West Bengal, India, to take the bouquet, memento, trio and souvenir. Sir, please come to the stage. Now I request Professor R.I.H.S Sahu, Government Women's College, Sambalpur. Sir, please come to the stage. Professor Dr. Umakant Tripathi, IIT, R.I.H.S Bhogai, please come to the stage. Now we are getting an opportunity to have our DC, Hockey University speaker, please come to the stage and give us a working of please. Association Chairperson, Professor S.K. Agarwal, FM University. Sir, please come to the dais and take your chair. And our resource scholar, Sir, Tushar Kanti Rao, IIT, ISM, Dhanbad.
Very good afternoon to all the students. Thank you to all for giving me such a beautiful opportunity to present here. First of all, I want to give a heartfelt thanks to my respected Professor Guide, Professor R.I.H.S for giving me a beautiful opportunity to stand in Odisha and deliver my presentation. So first of all, my topic name is Angela Gatman as a therapy candidate targeting now people in kindness. So students, so what is the biggest dilemma in the life, or what is the biggest build in the life? That is the difference between a normal person and an abnormal person. So when there is an abnormality which arises due to the neurological disorder, at that time it's due to a neurological disease. So neurological disease, what are the things we are getting? What are the things we are experiencing when we are suffering from the neurological disease? We are experiencing loss of sense, changes, consciousness, and the things. But why it happens? Because we are part the life that was sustainable. That is only because of the protein excretion. So when protein excretion, when protein translation occurs, at that time life is going to survive. Then there is a misfolding in the protein occurs. So whatever, at that time there will be aggregation of the protein, which is leading to the neurodegeneration. So two types of neurodegenerative diseases are there. One is Alzheimer's disease, Parkinson, and Amyotrophic. Next. So in tauopathy, what happens? So generally tau is a strike that is used in a rope for binding the sticks. So you see where your father is taking some sticks to hook the wood, and that time he is wearing a rope, and so tau protein is used to bind the microtubules. So it is generally good protein. But what happens when phosphorylation occurs? So that phosphorylation is occurring through kinase. When phosphorus is transferred to that protein, at that time when the tau protein gets hyperphosphorylated, at that time what happens? It forms neurofibrillary tangles. You see here that neurofibrillary tangles is forming. After it is forming, you use the neurofibrillary tangles. At that time it is accumulated. When neurofibrillary tangles get accumulated, at that time, so there is a disturb in the neural communication. When there is a disturb in the neural communication or the synaptic communication, at that time it is lead to a neurological disease. Next. So my idea, my objective is to identify and monitor present tau protein kinase inhibitor structures as part of screening and molecular talking. So next. We have done. Have you seen one lock and key? Students, have you seen a lock and key? So what we are doing? We are using a key to open the lock. Similarly, when we are pressing down, when we are operating some going through a disease condition, at that time we are applying the lock and key model to go through a disease diagnosis process. So that lock and key model is based on molecular computational testing that introduces the binding affinity of the ligand. So generally the docking is divided into rigid docking and flexible docking, where the both the receptor and the target are fixed, and that is sent to the rigid docking, and when the receptor and target are moving, so in a different configuration, it is sent to the flexible docking. Next. So these are the steps that are involved in the molecular docking, protein preparation, binding site analysis, ligand preparation, docking. Next. So this is the flow chart of the protein preparation. How protein is preparing from the protein database. Students, you see that in your school, in your college, there are libraries there. So every protein is accumulated in one database library. That is called as a PDF, protein database. Okay. So from the protein database, we can download the structure that structure from the product. Next. So, going to the molecular docking, we are doing some that one is the binding site analysis from the literature format, followed by the post-test, and we are also doing the ligand preparation. Ligand preparations, we are driving the ligands from a library, and under the guidance of Professor R.I.H.S we have discovered a 5,000 natural ionic library. So that is the biggest achievement of our lab. And from that natural library, we are generally talking with the ligand with atoms of the receptor proteins. After that, we are inhibiting its transcription. So this is the docking pyramid you are to see. So as there are the docking system. Next. So generally whatever the compounds that are taking, whether it is toxic or not toxic, that can be visualized for sweet again. Different advantages of water solubility, possibility, thermodynamics. Next. So this is the sweet sensitivity of benzene, whether it is toxic or not toxic. So from the bioactivity radar diagram, we are finding that it is not toxic. Next. So this is the graph. The graph we are clearly visualizing immobilicity is generally how a drug is acting on the molecular level. It is used for drug activity. Next. This is the speed reaction diagram for different types of water, solid, minerals, carbon alkali, different types of bonds. Next. So this is the molecular docking process. So this is the molecular protein. This is ligand docked in that complex level. Next. So this is the conclusion. This is what is highlighted in the protein therapeutic targeted supporting its proposal for the topography. However, we are going to do some further molecular dynamic simulation and experimental validation to use that as a proper drug in the therapeutic. Thank you to my respected director and all our members and Ministry of Education for supporting us and to start here. Next. Thank you to the Bhograi for giving connecting us with the nature and organizing such a conference.
Thank you. Okay, we will discuss in the long term. Actually, one announcement. The talk is for students. Please keep silent. Otherwise, it is not fruitful for you. Please silent. Next.
Our next scholar, Ajit Kumar Sahu, Charamka Mahavidyalaya, Charamka. Sir, please come with us.
Good afternoon, everyone. Good afternoon, everyone. My name is Ajit Kumar Sahu. I am lecturer in physics in Charamka Mahavidyalaya, and also I am doing my PhD under supervision of Dr. Chairman Vidya in IIT Bhograi. So today I will talk about drafting and membrane-mediated interaction of biomolecular catalysts. Next. So, what is the story of cell? We know that the cell was first discovered by Robert Wood in 1665, and after that, with the development of microscope, we discovered many other things about cell like nucleus, very membrane-bounded organisms. But what happened in 2009? Something groundbreaking happened. That first time we realized that cells can organize without any membrane organelles, without membranes, it can organize itself. So next. So what is biomolecular catalysis? So these membraneless organelles are known as the biomolecular catalysis. So these are formed by liquid phase separation, and the main thing is they are not bounded by any physical barrier or any membrane. Next. So there are many experimental studies also by physics. So any a particle or a larger particle wants to travel from one side to the other side of the cell, it will go through by the process of wrapping. For example, you can see the coronavirus. So it is going from one outside of the cell to inside of the cell by the process of wrapping. Next. So we will have two main objectives, that a membrane bounded organelle can be get wrapped. So the question is, can a non-membrane bounded organelle get wrapped by a membrane? And the second question is, for example, you have two droplets or two biomolecular condensates, so they will interact each other or repel each other. So next. So to study this, we can use some fundamental physics laws, energies. For example, the surface energy. You can see this is basically the energy of the outer layer, which is basically the energy required to maintain or create a surface. So this is very interesting phenomena. For example, insects can walk on the water, or if you drop a pin on the surface of water, suddenly. Next. And next energy is basically the bending energy. This is the energy required to bend something. So if you want to bend something, it is not free. You have to put some energy to bend it. So including all this, we will construct this Hamiltonian. I am not going to detail due to lack of time. Next. So basically we are using this surface evolver method. So here we construct our model by larger triangle and then gradually refine it to approach higher accuracy of minimum approach. Next. So basically I am going to the regions part now. So in the region we can conclude that a droplet cannot be get completely wrapped by the membrane, rather than it will get trapped in the metastable state. So here we have basically three states. So in the third case, the droplet is not at all going inside. Next. So this is the energy analysis that we did. Next. So we found that the droplet is not getting completely wrapped, or rather than it's staying with a stable length. Next. So next thing is like in two droplet are present on the membrane, so they will interact or repel each other. So we found that they can interact each other or they can repel each other depending on the tension of the membrane. If the membrane tension is much higher, then they will repel each other, but if the tension is low, they will interact each other. So these are the conclusions. So I would like to thank my supervisor and our collaborator. Thank you.
Any question? Okay, so let us thank our for a nice talk.
Thank you, sir. Our next research scholar, Subodh Kumar Sahu, IIT ISM, Bhograi. Sir, please come to the slides. Thank you.
Good afternoon, everyone. I am Subodh Kumar Sahu, working as a chairman under the supervision of Professor Martin Tripati, Department of Physics, IIT ISM, Bhograi. So, first of all, I would thank to all the members of the Random 2025 and my guide to give me this opportunity to present my topic, leader and non-leader physical strength of bilirubin. So, here we are going to discuss about non-linear and linear properties of bilirubin. So, let us first introduce about bilirubin. Next slide. So, what is bilirubin? When the red blood cell break down, the hemoglobin present in the red blood cell will make to hemoglobin, and in different states, then the hemoglobin will convert to the bilirubin. Initially, the bilirubin is in unconjugated state, which is water insoluble, but it will reach to the liver by the help of a protein known as albumin. Then the liver will convert the unconjugated bilirubin into conjugated bilirubin, which is water soluble. this is the opposite of the self-perceived effect, where you have the negative refractive index and only divergence in bodies are observed. So now to test the fluid, based on historical phenomenon property, we have used the special technique, that is the Least-Count technique, which is very sensible and level free of slippery. So there are two types of studies here. One is closed aperture, where we discuss about the non-linear refraction, and then in open aperture, we have discussed about non-linear absorption. So this is the closed aperture Least-Count technique, where our aperture is used to measure the center of proximity, which is responsible for the non-linear refraction. This is the closed aperture study. One is self-focusing effect and another is self-focusing effect. Self-focusing effect and evaluation quality, and in refocusing effect is going to evaluate blue market of water, from which we can detect non-linearity of the fluid. Next one. So this is the experimental result, which shows that as concentration increases, the non-linearity also increases. And the red line here is using the AVM fitting from Next one. This is the report from the fitting. We have evaluated the BP value. Then using the formula first one, we have evaluated the AP value. And here it is given that as the concentration increases, the value. Next one. So this is the N2 versus concentration graph. From using this, we can suppose we have the we have sample. Here we use the experiment to determine the AP value, and corresponding concentration can be determined. So from this graph, it is observed that at very low concentration, we can detect the value. That is the advantages of this technique. This is the conclusion that we see the self-perceived effect. And next time we will do biological samples. We have this problems. So thanks to Professor everybody for that valuable support, and Professor Somin for all members of violations, and thanks to Sir India.
Thank you for that explanation. I have a question. So, why this scan is called as G-scan?
Sir, actually, we are scanning it in the Z-axis within the focal region, the Gauss range, where we are getting the focusing and defocusing. That's why it is called.
So, thank you for attending for this session. Thank you.
Thank you. Good afternoon everyone present here. On behalf of the Department of Physics and R.I.H.S BHOGRAI, it is my privilege and honor to welcome you all to this dedicated session. Now, with due respect, I take the opportunity to invite our esteemed dignitaries to the dais. Now, I request our Honorable Chairperson, Professor R.I.H.S BHOGRAI, to come and take the chair. Sir, please come to the stage. Now, we are deeply honored to have with us Professor Tripathi, Vice Chancellor, Fakirmo University, R.I.H.S, as our chief guest. Sir, please kindly come to the back. We are privileged to welcome our chief speaker, Dr. Sukadev Sahu, Department of Physics, MIT Durgapur, West Bengal, India. Sir, please kindly come to the back. Now I request our organizing secretary, Professor Tapal Kumar Panda, to come to the dais. Now we shall proceed with the lighting of the ceremonial lamp. So I request our dignitaries to light the lamp. Now I request our students to offer chandanas, uttariyas, flower bouquets to our dignitaries. Now I request our Honorable Principal Sir to offer memento to our Vice Chancellor Professor Santosh Kumar Tripathi. Now I request our Principal Sir Professor Misra to chair over the meeting. Thank you, sir.
Now, I request Professor Department of Physics regarding the rapid
Thank you, sir. Respected chief guests, honorable dignitaries on the dais, our principal, respected teachers, scholars, and dear students. It is my privilege to present the appreciative report of the two-day national seminar organized by the Department of Physics, R.I.H.S BHOGRAI. The seminar began with an inspiring inaugural session where our distinguished guests encouraged us to pursue knowledge with dedication and creativity. Their words gave a meaningful start to our academic journey. During the plenary sessions, eminent speakers delivered lectures on a wide range of topics. The discussion highlighted recent developments in quantum science, quantum technology by Professor Vasanta Kumar Panigrahi, quantum biology by Professor Vishwajit Pradhan, studies of quantum fluid plasma and the Yali University Laboratory by Professor Jajati Kesari Nayak. The keynote invited talks gave us valuable insights into both theoretical and perspectives and practical applications. Scholars and students also presented their research papers. The sessions were interactive, thought-provoking, and created a platform for exchanging ideas. The active participation of both presenters and audience enriched the seminar and made it truly productive. Overall, the seminar not only updated our knowledge but also motivated young minds to take up new challenges in research and innovation. On behalf of the Refugees Committee, I sincerely thank all the speakers, participants and the organizing team for making this seminar a memorable academic event. With this brief summary, I conclude my report. Thank you all.
Then I request Sukadev sir, please.
Good afternoon, respected Professor Santosh Kumar Tripathi, Vice Chancellor, University, Professor Vijay Kumar Mishra, Principal R.I.H.S, distinguished speakers and dignitaries of the dais, faculties and staffs of R.I.H.S BHOGRAI, and beloved students. Today I reached in this institute for attending this program. What I listened from Professor Shweta Parmeswari yesterday, some distinguished speakers have given their talks, valuable talks for our students. So what I saw today also, the speakers have given their talks in different fields like material science, cosmology, high energy physics, nuclear physics, condensed matter physics, AI. So dear students, now I think you are acquainted with the different branches of physics. Since you are continuing your BSc or graduation in this institute, after BSc I think you will appear in different national level examination and state level examination, like JAM and Central University examinations, State University examinations. After that, you will continue your MSc either in Central Government institutes or State University. Examinations like NET, JES, etc. And after that, you will be eligible for PhD in different branches. What you have got today, the brief idea about the different branches. Then you will be interested for any branch. Like any branch you are interested in, can continue. According to R.I.H.S, you never give up on what you really want to do. It may be challenging. With hard work, your determination and support of peers, your friends, parents, seniors and teachers, you will be able to succeed. I have a strong belief that you have the potential to give an impact, positive impact in the world, and you will make the name and fame of this institute great high level. Thank you all.
Thank you, sir. Now I request our award Vice Chancellor of University of R.I.H.S and Director of the Education, Professor Santosh Kumar Tripathi, to deliver his valuable speech, not for R.I.H.S, for our inviters and other personnel.
Esteemed Principal and Chairperson of the valedictory session, esteemed Chief Speaker, Professor Sahu, the Organizing Secretary, Professor Panda, esteemed resource persons present here who have already done their job, research scholars and students. पूरा चिठाटा देखुली सेतरे केवल ओडिया देवर रखा बे ओडिया रे कहले मते भलो हबो तमे ओडिया रे कहबा चेष्टा करिवे बिकॉज़ आई एम नॉट मैन आई एम नॉट फ्रॉम फिजिक्स नॉट फ्रॉम एडवांस फिजिक्स मो बहुत खुशी जे R.I.H.S BHOGRAI पिला मान को अनुरोध करबी जदि निज भितर कथा कहबार अछि दया करी बाहर को जान पिला मान को अनुरोध करबी निज भितर कथा कहबार अछि बाहर को जान R.I.H.S BHOGRAI बहुत बड़ काम करिछि एते जे रिसोर्स पर्सन को एकाठी करिछि बीके पाणीग्राही को आरंभ करी अनेक जगह अनेक लोगों को निमंत्रण करिछि एवं मो सुनी निमंत्रण रक्षा करी समस्त आछि जोथि मो अंततः R.I.H.S BHOGRAI पे गोटे करताली आशा करिछि नाइजर भुवनेश्वर हो बा कोलकाता IIT NIT ISM IIT BSCUT FMU and MSCBU सबुठु जो प्रख्यात वैज्ञानिक माने आसी कर्मशाला जोग देले संपादन जोग देले सेमान को मध्य धन्यवाद देबी ता कारण हला मो एठी जते थर आसी टिके कष्ट करिया पड़छ कष्ट है जे भाबिया पड़छ जीवी कि नाही कारण गोटे पार्ट उत्तर ओडिसा रे अछि अनुष्ठान बढ़िया हेछि किंतु आग्रह अछि देखिबा पाई ता संगे भारतर जो कष्ट अछि से पई अनेक तर चिंता करिया पड़े मो R.I.H.S BHOGRAI को जीवी कि नाही किंतु जो रिसोर्स पर्सन माने आसी एठी जोग देई समान मूल्यवान वक्तव्य रखिछन आकर्षण छड़ा किसी नुहे आकर्षित होगी आसुँच मु भावुची R.I.H.S BHOGRAI सहित किसी गोटे आकर्षण अच्छी जहाँद्वारा कि से आसो मु गर्वित जे मो विश्वविद्यालय अधीन किसी विश्वविद्यालय अच्छी R.I.H.S BHOGRAI गोटे अग्रगण्य अनुष्ठान हिसाब से अनुष्ठित हाँ से मटेरियल साइंस हो कस्मोलॉजी हो AI हो ये सब विषय आलोचना कर अत्यंत उपादेय एवं पिला माने एतुर किछि शिखिथिबे बोली मु आशा करूछि गोटे सेमिनार कौन घटे कहा घटे प्रथम कथा किसी स्पीच दिया जाए वक्तव्य रखा जाए द्वितीय कथा टेक्निकली किसी डिस्कशन करा जाए तृतीय कथा किसी लोग पोस्टर प्रेजेंट करती किसी लोग पेपर प्रेजेंट करती एवं व्यक्ति भितर समन्वय घटे इंटरैक्शन से इंटरैक्शन प्रोसेस में समस्त किसी ना किसी शिखती जे वक्तव्य रखती जो प्रश्न पचरा जाए से विषय से शिखती जो मैंने पोस्टर प्रेजेंट करते जे आसेस करते प्रश्न पचरा से भी किसी शिक्षा हुए जो मैंने प्रेजेंटेशन दिखती जदि प्रश्न पचरा जाए से भी किसी तथ्य आदान प्रदान हुए ये सब भितर शिक्षा रही जाए भितर जोटा कि मुख्य उपादान किसी शिखा पिला कौन बहुत बड़ा बड़ा लोग आसते जदि पिला इंटराक्शन करे परिचित विषय जाने भी बहुत कथा भविष्य पिला ही फिजिक्स पिला जो अच्छा भावी से कैरियर करेंगे वैज्ञानिक हिसाब से हो अध्यापक हिसाब से कैरियर कला बेले पूर्व यदि एमती किसी व्यक्ति विशेष आसती जो मैंने ओडिशा नुहे ओडिशा बाहर सारा पृथ्वी ना कमाई से भाया व्यक्ति विशेष संस्पर्श आसे परिचय पिला भी बहुत लाभ मोटिवेशन इज अनदर फैक्टर which is also there as a part of seminar ये सब को मिसेले देखा जाए जे किछि किछि समस्त नै कि जो जानती सेटा हला संपाद समस्त पे किछि उपादान और थाए जोरे पिला माने बेसी आग्रही कलाकारी का सांस्कृतिक कार्यक्रम थिला मैं जाने सांस्कृतिक कार्यक्रम यदि प्रथम दिन संध्या थाए एवं द्वितीय थाए खाଇବା पिबाटा के करो साधारण भाव नॉर्मल खाଇବା पिबा भल खाଇବା ताहले जाय कि गोटे सेमिनार पूर्णांग पे करियो तो मु भाबुची आज जहा उत्साह देखली से पिला मान को बळर हो बा एठी जो प्रेजेंटेशन दिनटा देखली बहुत उपादेय थिला एवं निश्चित भाव में आगो को पदार्थ विज्ञान रे कोन गवेषणा हो जाय कोन आगो को काम हो मो बेले बायोसाइंस को फिजिक्स संगे मिसाई करबो तो एबे जो पेपर देखली को काम समय भीतर तारे देखली जे बायोसाइंस बायोफिजिक्स पर रिसर्च करा जोड़ा कि निश्चित भाव में कागज जो कारण एबे जो मल्टीडिसिप्लिनरी रिसर्च उपरे आग्रह प्रकाश करा होची प्रत्येक विषय मिसिले नवा जिनस बाहर होची सेटा स्वीकार करा है जो तीनटा पेपर प्रेजेंट होला सेतिर मु अनुभव करू एवं जहां देखुतली सेतिर मध्ये देखुतली material science, energy and environment, how they can go together. Studies can be done on 3 aspects. This is also a part of this seminar, and really I am happy that people have discussed about the challenges in modern physics. What are going to be the challenges, what are going to be the new areas to be discussed, to be researched, and finally how physics can go ahead with a better contribution to the society. That was perhaps the theme of this seminar. Therefore, I again thank the organizers that they have done the right thing by choosing this topic, and they need congratulations, they need appreciations from the university, from myself. I appreciate the effort of R.I.H.S BHOGRAI, especially the organizing secretary and organizing committee. It's a lot of appreciation, lot of congratulations, and I also congratulate and thank the principal that he permitted this type of seminar to be conducted in R.I.H.S to open the eyes of the students. They should know, they should go beyond the classroom, they should know what are the future areas where research is possible. They can contact, they can assimilate themselves with the new topics. That is possible through this seminar. Therefore, I am very happy. The other thing I should say that students, please participate to learn something. तो हमारे का हाथ में क्या हाथ में उठे नोटबुक भी दे यदि नोटबुक नहीं ताले बोलते 4 घंटे भी हम आगे सीखी बात और आशा रहिबो आगामी दिन में जेतबे कोनोसी प्रकार ए भलिया दामिकिया संवाद हबो वैल्यू सेमिनार्स कंडक्ट हबो दया करके आपरे गोटे खाता धरि आसे चेष्टा करबो एवं किछि हेले नवा चेष्टा करबो मतलब केते बेले अवसर समय बसला बेले से खाताटा पढी पारिबो ताले बहुत କଥା जाने मु आशा करबी प्रत्येक लोकको यदि ସେମାନେ आने नथिले कॉलेज तरफर ताको गोटे प्रोवाइड करबो दे आर आल्सो पार्टिसिपेंट्स सो नेक्स्ट सेमिनार जहां भी लोग छाड़ी और नीचे ऑब्जर्वेशन अच्छी सेटा भी करबो पिला माने जेतोले रूम को सजाई जति बेलून लगी बेलून लगेला कोन होची Balloon is not our tradition at all. Full our tradition. Full लगाइले बंद थोइले कोनसी जगह रे सेटा छड़े दिया जाय परिबो balloon रे जो चिन्ह एक कपड़ा जो तयारी हेतो जति पैसा तयारी हेतो रंग करबा को मते 5 लाख टका खर्च हो अदथा कॉलेज पर से बोझ पिला माने लदन तो आपण माने का मिस करे द्वितीय कथा मो अनुरोध करबी कि दीपक प्रोविजन भी बंद करो छोट कक्षा थैंकफुली एटी एसबीसी लगा है कि आपको बंद करा है कि किसी जगह खोला है दीपर प्रभाव हमें समस्त जानि दीपर जहां बाहरिबो तो आमे ठाकुर को संगे जोग दे कि सेटा को चलो जे किंतु ता बदल यदि गछटी रखि से पानी देवार प्रबंध करिवे सेटा समस्त में गोटे मोटिवेशन हबो सेमाने गोटे सोशल मत जो झीटे फूल देला ताको जतका पैसा देला सी जानि फूलटा कोला सुखी एवं फूल चारि कड़े गोटे प्लास्टिक गुडा तेणु दया कर प्लास्टिक गुडा फूल सेटा दियंत नाही प्रत्येक लोक जे आसुछन ताको गोटे चारा गछ से नले ता कोनसी जगह रे पे परिवार ता जेते रे गोटे आउ जणो काहे दो पुतिया से ट्रेडिशन दया कर तयारी करन एवं ये महाविद्यालय प्लास्टिक फ्री करने का चेष्टा करें। बहुत धन्यवाद धन्यवाद।
এই পরিপ্রেক্ষিতে মোর আউ কিছু भी কইবার নাই, কারণ যে কথাগুলো কইবার ଥିଲା ସାର୍ ସମସ୍ତ କଥାକୁ ଗୋଟି ଗୋଟି କରି ସମସ୍ତଙ୍କ ପାଖରେ ବୁଝେଇ ଦେଇଛନ୍ତି। এই যে বেলুন টাকিবার কথাটার আরম্ভ করে চারা গଛ দেওয়া পর্যন্ত কথা, ମୁଁ ଯେତେ ଜାଗାକୁ ଯାଇଛି, ଯେଉଁ ଅତିଥି ମାନଙ୍କ ପାଖକୁ ଯାଇଛି, ମୁଁ ସାର୍ଙ୍କ ପାଖରେ ସତ କଥା କହୁଛି, ମୁଁ ସମସ୍ତଙ୍କ ପାଖକୁ ସାର୍ ଚାରା ଗଛ ନେଇକି ଯାଇଛି ଏବଂ ସମସ୍ତଙ୍କୁ ସାର୍ ଦେଇଛି। ମୁଁ କେବେ ଇଏ ଦହିଗୁଡ଼ା ଫୁଲକୁ ନେଇକି ଯାଇନାହିଁ। ତେଣୁ ସାର୍ଙ୍କ ଉପସ୍ଥିତି ଆଜି ନିଶ୍ଚିତ ଭାବରେ ସାର୍ଙ୍କ ପାଦ ତଳେ ଅନୁଷ୍ଠାନରେ ପଡ଼ିଛି। ମୋ ପ୍ରିନ୍ସିପାଲସିପ୍ ସମୟରେ ମୁଁ ସାର୍ଙ୍କ ସହିତ ଅନେକ କଥା ହେଇଛି ଏବଂ ମୋର ଯେଉଁମାନେ ସହକର୍ମୀ ସେମାନଙ୍କ ସହିତ ବି ସାର୍ଙ୍କ ମିଶି କଥା ହେଇଛି। କେଉଁ କେଉଁ କାର୍ଯ୍ୟକ୍ରମ ହାତକୁ ନିଆଯାଇପାରିବ, କେଉଁ ନୂଆ ନୂଆ କଥା ସବୁ କାର୍ଯ୍ୟ ହାତକୁ ନିଆଯାଇପାରିବ, ସେ ବିଷୟରେ ସାର୍ଙ୍କ ସହିତ ପୁଙ୍ଖାନୁପୁଙ୍ଖ ଭାବରେ ଆଲୋଚନା କରାଇଥିଲେ ମଧ୍ୟ ସାର୍ ଯେତିକି ବିଶ୍ୱସ୍ତ ସାର୍ଙ୍କ ପାଖରେ ମୁଁ ପ୍ରତିଶ୍ରୁତି କରେ। ଅନୁଷ୍ଠାନ R.I.H.S ଓଡ଼ିଶାର ଗୋଟିଏ ଅଗ୍ରଣୀ ଅନୁଷ୍ଠାନ ହିସାବରେ ସାର୍ ଆପ୍ରିସିଏଟ୍ କରିଛନ୍ତି। ସାର୍ଙ୍କ ଆଶୀର୍ବାଦର ଆମ ପୂର୍ଣ୍ଣ ଉପରେ ରହିଛି। ଯେତେବେଳେ ଯାହା ଦରକାର ହେବ ତାହା କରାଯିବା ପାଇଁ ସାର୍ ମୋ ସହିତ କଥା ହେଇଛନ୍ତି। ଇଏ କଣ କଥା ନୁହେଁ। ସାର୍ କହିବେ ଯେ ତମେମାନେ କର, କିଛି ବ୍ୟସ୍ତ ହେବାର ନାହିଁ, ମୁଁ ତୁମମାନଙ୍କ ପଛରେ ଅଛି। ଏ ଆଶୀର୍ବାଦ ସାର୍ ଆମ ମୁଣ୍ଡ ଉପରେ ସବୁବେଳେ ରହୁ, ଏ ଆଶା ନିଶ୍ଚିତ ଭାବେ କରିବି। ଆଉ ଆଜି ଯେଉଁମାନେ ନିମନ୍ତ୍ରିତ ହୋଇ ଆସିଛନ୍ତି, ସ୍କଲାରମାନେ ଆସିଛନ୍ତି, ଗୁଣିଗାଣୀ ବ୍ୟକ୍ତିମାନେ ଆସିଛନ୍ତି, ସମସ୍ତେ ଏଠାରେ ସେମାନଙ୍କର ଟପିକ୍ ଉପସ୍ଥାପନ କରିଛନ୍ତି। ସମସ୍ତେ ଏହାକୁ ଅନୁଭବ କରିଛନ୍ତି, ଶିଖିଛନ୍ତି। ସାର୍ ଯେଉଁ କଥା କହିଲେ ଯେ ପିଲାମାନଙ୍କ ହାତରେ ଗୋଟେ ଗୋଟେ ଟିକା ଖାତା ନ ରହିଲେ ଏମାନେ କେବଳ ଶୁଣିବେ, ଶ୍ରୁତି ମଧୁର ହେବ ସିନା, କେବେ ସ୍ମୃତି ମଧୁର ହେବ ନାହିଁ। କିଛି ମିନିଟ୍ ପରେ ବା କିଛି ସମୟ ପରେ ସେ କଥା ଉଭେଇଯିବ। ତେଣୁ ପାଖରେ ହାତ ଟିକା ଖାତାଟିଏ ଥିଲେ ଯେତେବେଳେ ବି ଓଲଟେଇ ଦେଲେ ବି ନିଶ୍ଚୟ ଚାରିପଦ କଥା କାର୍ଯ୍ୟ କରାଯିବ। ଇଏ କ'ଣ ବଡ଼ କଥା ନୁହେଁ। ପିଲାମାନଙ୍କୁ ମୁଁ ଅନୁରୋଧ କରିବି, ସେମାନେ ସେମାନଙ୍କର ଖାତା ଯେଉଁ ଅଛି ସେମାନେ ଆଣିବେ। ତେଣୁ ଆମ ଟିଚରମାନଙ୍କୁ ମଧ୍ୟ ମୁଁ ଅନୁରୋଧ କରିବି, ଯେଉଁମାନେ ଉପସ୍ଥିତ ରହୁଛନ୍ତି, ବୁଝନ୍ତୁ ନ ବୁଝନ୍ତୁ, ଜାଣନ୍ତୁ ନ ଜାଣନ୍ତୁ, କେତେ ଗୁଡ଼ିଏ କଥାକୁ ଟିପିକି ରଖନ୍ତୁ ଯାହା ସେମାନଙ୍କ ପିଲାମାନଙ୍କ କାର୍ଯ୍ୟରେ ଲାଗିବ। ସେମାନଙ୍କ ପିଲା ସାଇନ୍ସ ପଢ଼ୁଥିବେ, ସେମାନଙ୍କ ବନ୍ଧୁବାନ୍ଧବ ପିଲାମାନେ ସାଇନ୍ସ ପଢ଼ୁଥିବେ, ବା ଯେଉଁ ବିଷୟରେ ବି ଆଲୋଚନା ହଉ, ସେମାନେ ନିଶ୍ଚିତ ଭାବରେ ତାଙ୍କ ପିଲାମାନେ ନିଶ୍ଚିତ ଉପକୃତ ହେବେ। ତେଣୁ ଏ ଆଉ ଅଧିକ ସମୟ ଦେବି ନାହିଁ, କାରଣ ସବୁ କଥା ଏଠି ସରିଯାଇଛି। ଆଜିର ଦୁଇ ଦିନର କାର୍ଯ୍ୟକ୍ରମକୁ ଯେଉଁମାନେ ଠିକ୍ ଭାବରେ ସଜାଗ ଦେଇଛନ୍ତି ମୋର ସହକର୍ମୀ ବନ୍ଧୁମାନେ ଏବଂ ଆପଣମାନେ ଯେହେତୁ ଏବେ 2 ଦିନ ଧରି ଆମକୁ ସହଯୋଗ କରିଛନ୍ତି, ସେଥିପାଇଁ ମୁଁ ଆପଣମାନଙ୍କୁ କିଛି କରୁଛି ଏବଂ ନିଶ୍ଚିତ ଭାବରେ ଆପଣଙ୍କୁ ଧନ୍ୟବାଦ ଦେଇ ମୁଁ ଏଠାରେ ବକ୍ତବ୍ୟ ରଖୁଛି। ପରବର୍ତ୍ତୀ ପର୍ଯ୍ୟାୟରେ ମୋ ପ୍ରଫେସର ତପନ କୁମାର ଅନୁରୋଧ କରିବି ସେ ବୋର୍ଡ ସାର୍ ଆମର ବର୍ତ୍ତମାନ ସାର୍ଟିଫିକେଟ୍ ଡିଷ୍ଟ୍ରିବ୍ୟୁସନ୍ ରହିଛି। ସାର୍ଟିଫିକେଟ୍ ଡିଷ୍ଟ୍ରିବ୍ୟୁସନ୍ ପାଇଁ
Now we request our chief guest, Honorable Professor Santosh Kumar Tripathi, Vice Chancellor of Pune University, Baleshwar, to distribute certificate to our research scholars. May I on the stage research scholar Pradeep Kumar Rao, lecturer in physics, DK College. Next, Tushar Kanti Rao, JRF, IIT, ISM, Dhanbad. Sir, may I on the stage? Subodh Kumar Sahu, research scholar, IIT, ISM, Dhanbad. Ajit Kumar Sahu, Charanha, Mahavidyalaya, Bhadrak. Ipsita Parida, research scholar, MSCB, University, Balikata. Abhijit Behra, MSCB, University, Balikata. Anurag Jaina, research scholar, MSCB, University, Kalkutta. Honorable R.I.H.S Scholar, MSc, University, Kalkutta.
Honorable Chief Patron of this ceremony and our VC Sir Santosh Kumar Tripathi Sir of the University and our most of the respected person and our patron our Vijay Kumar Mishra Sir our college अध्यक्ष एवं सबू सभार आयोजन ପାଇଁ ତାଙ୍କରି ପରାମର୍ଶ ସମ୍ମତି ହେଇଛି ଏବଂ ନେକ୍ସଟ chief speaker Sukadev Sahu sir NIT Durgapur and our other dignitaries of the R.I.H.S and our participants प्रथमे आमर ये प्रोग्राम का आयोजन करने मु प्रथम इंस्पिरेशन पाई आमर संतोष अग्रवाल सर जी की एफएम यूनिवर्सिटी फिजिक्स हेड तेणु तांकरी गोटे बड़ गाड़ी मत जहाँ किसी भूल किसी रही जाए कमी आम ठीक करवा कमी आम आगे जापर केमती कर से परामर्श जमी सब देवे सम्मानित थैंक्स सर जमी आप सब हाथ रखिथे और सब आगे केमती बढ़ा प्रोग्राम केमती आयोजन करवा से प्रति आमको दिग्दर्शन दे थैंक यू सर VC FM यूनिवर्सिटी सी आमको सब रास्ता देखाती केमती आम आगे जावा एवं केमती आम कॉलेज अलग अलग पाठ पढ़ा व्यतीत आम केमती आउ किसी कार्यक्रम करवा कहीं जो न्यू एजुकेशनल पॉलिसी अनुसार पाठ क्लासरूम सहित रही आम केमती अलग किसी काम द्वारा पिला रिसर्च ओरिएंटेड कर रिसर्च प्रैक्टिकल जीवन नुआ एजुकेशनल पॉलिसी अनुसार रिसर्च निश्चित दरकार खाली क्लासरूम भीतर पाठ पढ़ले किसी हम तेणु आमर VC FM यूनिवर्सिटी से सब गाइडेंस दिखती जे केमती आम रिसर्च ओरिएंटेड हो आम एक्रेडिशन जो नाक एक्रेडिशन केमती आम ग्रेड केमती आम बढ़ाई से विषय में बहुत किसी परामर्श दिखती प्रोग्राम अशेष अशेष धन्यवाद प्रिंसिपल से हमको केमती गाइडेंस दिखती केमती आम कर इंस्पिरेशन डिसिप्लिन सेल्फ एडजस्टमेंट द टीचर्स केमती केमती से आमको सब गाइडेंस दिखती तेणु आज आम परिप्रेक्षी आज पर्यटन पहुँची पार्टी समस्ते केमती आम आसपारे केमती रे केमती खाइबे से सब आमको परिश्रम कराती आमको कहती कौ पटे कले कौन काम कले केमती आम एमतीका जगह पहुँची पार एमती प्रोग्राम को सक्सेस करें अशेष अशेष धन्यवाद जी भी आम आज भाषण କହିଲେ ଏବଂ ସେ ତାଙ୍କର ନିଜର ମଧ୍ୟ କିଛି ମାନେ ରିସର୍ଚ୍ଚ ବେସ୍ଡ जो प्रोजेक्ट अछि ଆମେ ତାକୁ କେମିତି ଆମେ ପାଇପାରିବା ଏବଂ ଆମ ପିଲା ମଧ୍ୟ କେମିତି ତାଙ୍କର NIT ଦୁର୍ଗାପୁର ରେ ଯାଇକି ତାଙ୍କର जो प्रोग्राम ଗୁଡାକ ଅଛି ସେଟା ମଧ୍ୟ ଆଟେଣ୍ଡ କରିପାରିବେ ସେ ବିଷୟରେ ମଧ୍ୟ ସେ ତାଙ୍କର କିଛି କଥା କହିଲେ ଯୋଉଥିରେ କି ଆମେ ସମସ୍ତେ ତାଙ୍କର ରିସର୍ଚ୍ଚ ଆର୍ଟିକଲ ବିଷୟରେ ମଧ୍ୟ ଜାଣିଲେ ତେଣୁ ଅଶେଷ ଅଶେଷ ଧନ୍ୟବାଦ ସୁଖଦେବ ସାହୁ ସାର୍। ତାପରେ ଆମର IIT ଧାନବାଦ ଏବଂ MSc यूनिवर्सिटी एवं FM यूनिवर्सिटी और अलग अलग यूनिवर्सिटी गुडा पिलाने रिसर्च स्कॉलर मैंने अशेष धन्यवाद जे से आम प्रोग्राम में पार्टिसिपेट कर प्रोग्राम विघ्नित कर अशेष धन्यवाद कहीं व्यतीत आम सेमिनार कौन मूल्य ना लोक मैंने बाहर आसे IIT धनबाद IIT NIT आर्टिफिशियल इंटेलिजेंस जो प्राइवेट सेक्टर सब पार्टिसिपेट्स एवं इनवाइटेड स्पीकर्स जो द्वारा सेमिनार 15 जन थे माने इनवाइटेड स्पीकर जो बाहर एवं ओडिशा भीतर परिश्रम आमको यही परिप्रेक्षी सेमिनार को सफल करने आगामी दिन में जमी आम सक्सेस जमी आज सक्सेस है भावुँ तेणु से अशेष अशेष धन्यवाद आम उपर से दया रखी और दरकार हुए कौन समय आम पिला किसी कौटी दरकार पड़े से साहय नहीं पारे और चाहिए किसी मात्रा हेल्प करेंगे VCC कोलकाता साइंटिस्ट जो एजुकेशन लाइन से मतलब कथा देगले जे वर्ष 3 जन पिला से निश्चित प्लस 3 थर्ड इयर 3 जन जो पढ़ुଛନ୍ତି सेमान से समर कोर्स रे ताकर से एनरोल करिवे एति कथा तो कहि दिए आपण स्कॉलरशिप आकार में भी एवं 3 मास पई रिसर्च आर्टिकल गुडा केमति लिखुजे रिसर्च केमति होची से विषय मध्ये समान को कहिबे तापर आउर मध्ये हम सुखदेव साहू सर जो बसते NIT दुर्गापुर से मध्ये हम कथा देछथि कि आपण 3 जन पिला व्यवस्था पठे प्लस 3 थर्ड ईयर पिला को जो माने हमें जाय जीवु एवं समान ताको एनरोल करी समान समर इंटर्नशिप प्रोग्राम जो होउची सेबा कर मध्ये समान ताको पार्टिसिपेट करे एटा हम माने बहुत धन्यवाद जे समान जो हमें आज ए सेमिनार का सक्सेसफुल होला बोली भाबिला नले समान बिना हमें कोठी न तेणु से अशेष अशेष धन्यवाद तापर आमर स्टाफ टीचिंग नॉन टीचिंग स्टाफ एमान हमको सहयोग करछथि तेणु ए 2 दिन सेमिनार रे बहुत लोक अछथि जो हमर सेमिनार को सक्सेसफुल करिया पई आज 2 दिन मेला राति दिन परिश्रम करछथि आमर टीचिंग और नॉन टीचिंग स्टाफ और R.I.H.S कॉलेज मान और स्टाफ मान अशेष अशेष धन्यवाद तापर लास्ट पार्ट नॉट द लिस्ट आमर पिला मान रहिछथि जो फिजिक्स पिला फिजिक्स ऑनर्स फर्स्ट ईयर सेकंड ईयर थर्ड ईयर पिला से माने 2 दिन बसी हमर सेमिनार रे जहा किछि हेछि सेबा मध्ये भला भाबे सुनिजति एवं नेक्स्ट और केमति अप्लाई करबे से विषय मध्ये जानिया को पाइजति समान मध्ये अशेष अशेष धन्यवाद सक्सेसफुल करिया पई हमर डायरेक्टर रिसर्च एंड डेवलपमेंट सेल धीरेन्द्र कुमार जेना सर डॉक्टर धीरेन्द्र कुमार जेना सर एवं IQC कोऑर्डिनेटर हमर रंजित मंडल सर से मध्ये हमको ए प्रोग्राम रे केमति हम सक्सेसफुल होला से पई से मध्ये बहुत किछि कथा कहि दे और आशा मध्ये देखि हम तेणु आज यही परिप्रेक्षी समस्त धन्यवाद दे मो वक्तव्य
धन्यवाद कथा बाकी था आपण साथ तथरे प्रकृत देखा गले ऋषि सार प्रच्छन्न हाथ आप मुंड रही मो स्टाफ जो इनवाइटेड गेस्ट आसछथि समस्त सहयोग कार्य समाप्त होती समस्त पाखे चिरऋणी एवं दुराकृतज्ञ आउ थे आपण धन्यवाद
कैमरा